Now let us see the proofs for the identities we have seen initially. So first we'll prove that S of R2 is equal to 2 raised to R minus 1. So S of R2 means that is the number of ways of distributing R distinct objects to two identical boxes. First, let us assume that the boxes are not identical. Boxes identical then we will find how many distributions are possible such that each box is non-empty. Then any identical avuna case okay. So if the boxes are not identical, then so you have R distinct objects and two boxes. So you have distinct objects. So you have the first object, second object, third object and the rth object. Ini nammada boxes identical alla. Okay. So when you take the first object, let us look at what are the number of different arrangements. So endayil രണ്ട് ബോക്സ് ഉണ്ട് 6 ഓബ്ജക്ട്സ് ഉണ്ട്. അപ്പൊ എനിക്ക് ഫസ്റ്റ് ഒബ്ജക്റ്റ് രണ്ട് ബോക്സിലും പ്ലേസ് ചെയ്യാം. ഫസ്റ്റ് ഒബ്ജക്റ്റ് പ്ലേസ് ചെയ്യാൻ എനിക്ക് രണ്ട് ഓപ്ഷൻ ഉണ്ട്. അഗൈൻ the second object can also be distributed in two ways. So the third object can go to both the boxes and the rth object can go to the two boxes. So if the boxes are not identical, then there are 2 raised to r ways of distributing r distinct objects to two boxes. So these are all the possible distributions. So namukku r different objects undu. അപ്പോൾ 6 ഡിഫറെന്റ് ഓബ്ജക്ട്സിനെ ഞാൻ രണ്ട് ബോക്സിലായിട്ട് അറേഞ്ച് ചെയ്യാണ്, ഡിസ്ട്രിബ്യൂട്ട് ചെയ്യാണ്. ഓക്കെ. അപ്പോൾ നമുക്ക് കിട്ടാവുന്ന ഡിസ്ട്രിബ്യൂഷൻസിന്റെ എണ്ണം മാക്സിമം 2 raised to r ആണ്. അപ്പൊ ഇനി നമ്മൾ സ്റ്റേർലിംഗ്സ് നമ്പറിൽ നമ്മൾ കണ്ടുപിടിക്കുമ്പോൾ നമുക്കൊരു റെസ്ട്രിക്ഷൻ ഉണ്ട്. നോ ബോക്സ് മസ്റ്റ് ബി എംപ്റ്റി. ഓക്കെ. അപ്പം ഞാൻ ഓബ്ജക്ട്സ് പ്ലേസ് ചെയ്യുമ്പോൾ സോ there will be two cases. അപ്പോൾ നമ്മൾ ഓബ്ജക്ട്സ് ബോക്സസ് ഡിഫറെന്റ് ആയിട്ടാണ് എടുത്തിരിക്കുന്നത്. ബോക്സസ് ആർ നോട്ട് ഐഡന്റിക്കൽ. സോ വി ഹാവ് ടേക്കൺ ദ ബോക്സസ് ടു ബി നോട്ട് ഐഡന്റിക്കൽ. അപ്പോൾ ഔട്ട് ഓഫ് ദിസ് 2 raised to r ways of distribution, so there are two ways in which one of the box is empty. അപ്പം ബോക്സ് 1 വേണമെങ്കിൽ എംപ്റ്റി ആവാം. അപ്പൊ 6 ഓബ്ജക്ട്സും ബോക്സ് 2 വരാം. അതുപോലെ box 1 r objects varam, box 2 can be empty. So in the 2 raised to r ways of distributing, there are exactly two ways in which one of the box is empty. So the number of non-empty distributions will be given by 2 raised to r minus 2. Okay. So there are two of these distributions. In which all boxes are placed, all objects are placed in a single box. So therefore the number of non-empty distributions will be so that will be equal to 2 raised to r minus 2. And now this is the case where boxes are not identical. Any boxes identical aanengil so each distribution. അപ്പോൾ നമ്മുടെ ഈ total 2 raised to r minus 2 ആണ് നമുക്ക് boxes distinct ആണെങ്കിലുള്ള distributions. If the boxes are identical, so each distribution is repeating twice in this, each distribution is counted twice in this number 2 raised to r minus 2. So therefore, when the boxes are identical, the number of distributions will be given by 2 raised to r minus 2. Okay. അപ്പോൾ നമ്മൾ box 1ൽ ഒരു distribution കാണും, box 2ൽ ഒരു distribution കാണും. അപ്പോൾ boxes ഇനി ഞാൻ interchange ചെയ്താലും you are getting the same distribution in that case when the boxes are identical. So each arrangement is, each distribution is repeating exactly twice in this 2 raised to r minus 2. So 2 which divide here, that will give the required number. So now if the boxes are identical, the number of distributions is counted twice in 2 raised to r minus 2. So therefore S of r2 will be equal to 2 raised to r minus 2 by 2. So that is equal to 2 raised to r minus 1 minus 1. So that is the required number of bits. Now let us see the next result. So prove that S of r3 is equal to 1 by 2, 3 raised to r minus 1 plus 1 minus 2 raised to r minus 1, where n is greater than or equal to 3. Sorry, where r is greater than or equal to 3. So this is the number of ways of distributing r objects to 3 boxes. We have to show that that is equal to 1 by 2, 3 raised to r minus 1 plus 1 minus 2 raised to r minus 1. So this, for proving this result, we use the technique of mathematical induction. So we prove the result by mathematical induction. Now we have S of 3, 3. So S of 3, 3 will be equal to 1. So there is a number of ways of distributing 3 objects to 3 boxes that can be done only in a single way. So when r is equal to 3, so let us verify the result. So ഇപ്പോൾ നമുക്ക് induction prove ചെയ്യേണ്ടതാണ്. Initially ഒരു value prove ചെയ്യുക, then make an assumption, then k ക്ക് true ആണെങ്കിൽ k plus 1 ന് true ആണെന്ന് കാണിക്കാം. So we will show that the result holds for r equal to 3. So when r is equal to 3, so 1 by 2, 3 raised to 3 minus 1 plus 1 minus 2 raised to 3 minus 1, that will be equal to 1 by 2. So you will get 10 minus 4 varum. So that is 5 minus 4, which is equal to 1. So that is equal to the value of S of 3, 3. So therefore the result is true for r equal to 1. Now by mathematical induction, so assume that the result is true for r equal to k. So therefore S of k3 will be equal to 1 by 2, 3 raised to k minus 1 plus 1 minus 2 raised to k minus 1 varum. Now we need to show that the result is true for k plus 1. So let us find S of k plus 1, 3. By using the recurrence relation, S of k plus 1, 3 will be S of k plus 1 minus 1 upper k, then 3 minus 1 S of k2 plus n varum n into upper 3 into S of k minus 1, k plus 1 minus 1 upper k 3 varum. Okay. Now this will be equal to S of k2 that we have shown in the result 2 raised to k minus 1 minus 1 plus 3 S of k3 so that is 1 by 2 3 raised to k minus 1 plus 1 minus 2 raised to k minus 1. So that is 2 raised to k minus 1 minus 1 plus 1 by 2 into 3 which multiply 3 raised to k plus 3 minus 3 into 2 raised to k minus 1 varum. So that is 1 by 2 3 raised to k, then plus 3 by 2. Now you have minus 1, then 2 raised to k minus 1 minus 3 into 2 raised to k minus 1. So that will give you minus 2 raised to k kittum namukku. So this will be 1 by 2 3 raised to k. 3 by 2 minus 1 is 1 by 2 minus 2 raised to k. So that is 1 by 2 into 3 raised to k plus 1 minus 2 raised to k. So therefore S of k plus 1 3 is equal to 1 by 2 3k plus 1 3 raised to k plus 1 minus 2 raised to k. So therefore the result is true for r equal to k plus 1. So therefore result is true for r equal to k plus 1. So therefore by mathematical induction it is true for all r greater than or equal to 3. So that is the proof for this. Now next result is prove that S of r minus 1 is equal to rc2. This is the number of ways of distributing r objects to r minus 1 boxes. So no box must be empty. r minus 1 boxes or object which place cheyanam. There will be exactly one. So one of the boxes will contain exactly 2 objects. So the problem is to put now 2 objects into one box. So ഏതെങ്കിലും രണ്ട് object out of r നമ്മൾ select ചെയ്യുക, അത് ഈ ഒരു ബോക്സിലേക്ക് place ചെയ്യണം. So that can be done in RC2 ways. So therefore S of r minus 1 will be equal to RC2. So there is one box which contain 2 objects and the rest of the boxes will contain 1 object. Hence the number of distributions will be equal to the number of ways of selecting 2 objects. So that will be given by RC2. So therefore S of r minus 1 is equal to RC2. So this is the number of ways of proving this.